So if you go to Piazza, we do have our call for 115, 116 UTA applications. So if you're interested in being a TA for either 115 or 116, we actually hire TAs for both courses. So you're not a 115 TA, you're not a 116 TA, you're a 115 and 116 TA. And typically you'll start in 115 if you're hired as a TA. And then if you want to, you can express your interest in switching up to 116 or switching over to 116 in the next semester. The reason we do that is because 115 and 116, the enrollments are extremely different between spring and fall. Like right now we have almost 400 students enrolled in 116, so we need a lot of TAs right now. And next semester we're going to have about 200. So we don't need a lot more TAs, we need fewer TAs next semester. A lot of TAs will end up moving over to 115 because 115 is going to go from, I don't know the exact numbers, but like 300 to 700. So we hire, since we had to switch TAs every semester like that. Anyway, this is to start in the fall. Fall is the on semester for 115. We'll need a lot of support in 115 in the fall. And then in the spring 2022, we'll need more support in CSE 116. You get the idea. So if you're interested in applying, the application form is right here. You're going to need a resume, a copy of your transcript or your hub advising report, and a short explanation of why you want to be a TA. The deadline for this is April 25th. Get your applications in by then. If you have questions, I'm not going to read this whole post to you, but submit. The one thing I do want to say is if you have any hesitation, if you have doubts, if you're like, I don't know if I want to apply, I think it'd be neat to be a TA, but I'm not quite sure if I'm cut out for it, please, just apply anyway. Apply, let us make that decision. We'll let you know how you stack up. I've had a lot of really fantastic TAs over the years who almost didn't apply, and I would have been really sad if they didn't apply. So please, if you're on the fence about it, just throw your application in there. The worst thing we can do is say, oh, sorry, not this time. Not this time around, and then, it's whatever. But if you're on the fence, if you're thinking, man, I don't know if I'm cut out for this, please just apply. Usually if you're thinking like that, you're probably the type of person we want to hire as a TA. It's let me not give my opinions on it. But just apply. We'll reach out to you after the deadline. We'll process the applicants. We'll invite some of you for interviews. And then after the interviews, we'll make final decisions. Interviews will be during finals week. Just a heads up on that. Can I tell a story about how I had to convince you? Yes. Yeah. If you want me to, if you're cool with that. So Rin was actually one of those TAs, one of those students at the time, who I felt would make a great TA. He wanted to be a TA and just didn't want to apply. For whatever reason, he just wasn't applying. So after a lecture, this was, of course, way back in the day when we were actually in lecture halls for lecture, and it was approaching the deadline to apply, and I had my mind, I was focused on, I am going to attack Rin after this lecture. So after lecture, I'm like, that's all, folks. That's my last slide. Done with lecture. And there's a line of students, as there always is, lining up to ask questions. I'm like, hold on, I gotta go do some. And I just booked it, like, up. He was right in, like, the middle of the lecture hall. I just booked it up there, went right in front of the desk and said, hey, why haven't you applied? Get your application in right now. And then he applied, and of course, it worked out great for everybody. Rin's having a good time as a TA. Rin is a fantastic TA. It's just working out great for everybody. So if you're on the fence, please, I can't exactly rush up to you and smack you around or slam my hands on the desk, but I would, just apply so I don't have to miss out on that opportunity, on yelling at you. Just apply, and then I won't have to do that. You're welcome, Rin. And the other thing I want to mention, something I realize quite a few of you forgot about. I want to get a reminder out there. Review sessions every Wednesday. That's today. Every Wednesday, 5 to 7 p.m. Eastern Time. I added this to the office hour schedule to make sure that everybody's aware of this. If you're looking at office hours, review session exists. Here's the link to the details. Go to their Twitch page and watch them. Please start taking advantage of this. We're at a situation which kind of boggles my mind a little bit. I kind of get it, but I kind of don't. But we're at a situation where the queues for office hours are longer, have more students in them than the damn review session. Just go to review session. Their job is to review the content so you understand it. And the part that I get is that y'all have very specific coding questions. You want to show a TA your code and then get help specifically about your specific issue. My counterpoint to that is if you go to the review session and focus on the concepts and the content and ask them to show you examples and reinforce that material, then you're not going to have specific coding issues because you're just going to know what to do. Please start taking advantage of these. They're getting too few traffic. And if you do go to these, if the TAs get off track a little or they start, just joking around with chat, don't hesitate to get them back on track. Do whatever you have to do to be like, yo, I really need to see a recursion example. Can you show me a recursion example? Can you show me how to solve some question with recursion? Make them open up IntelliJ and get them to do whatever's going to help you learn the content. Don't let them just goof off for 2 hours. Or even worse, chat to just be completely dead and then they just leave after an hour or so. Push them, make sure that they're showing you what you want to see and helping you with what you need. Sounds like with so much LT4 questions, sounds like a lot of y'all need help with recursion. Ask them to show you recursion examples. Take advantage of that. Let them help you. Those of you who are still stuck on LT1 trying to figure out what first order functions are, ask them, hey, can you show me an example of a method that takes a function as a parameter? And get them to open IntelliJ and show you that stuff. Take advantage of them. They'll react. My point there is that they'll react off of chat. Whatever chat's doing, they'll play off of that. If chat's joking around, they'll joke around. If chat's asking serious questions about 116, they're going to give you serious help with 116. So don't let them get into a joking mood. There's just how much office hours are being crowded. I know a lot of you are struggling and have a lot of questions. Just go to office hour or go to the review session and ask them those questions. And the same applies after lecture. I'm happy to stay around after lecture and ask 116 questions. But I'm just playing off of chat. And a lot of times chat just wants to chat and joke around. So that's what we end up doing, which is fine. But if y'all have questions, that's your time to ask them. That, review sessions. Office hours should be more of a last resort. When you have that specific question, you're just absolutely stuck and you need very specific help. That should be very rare, in my opinion. And it's being used as like a first resort for a lot of students. So there's my pitch. Go to review sessions. I hope to see a lot of you in that review session tonight. Maybe I'll poke my head in and see how it's going. Maybe I'll yell at the TAs and get them on track and tell them to show a recursive example. With that, let's talk about WebSockets. Let's get into this. We have a lot of slides today. I'll probably be going at a fast pace today, especially since I wanted to take that 10 minutes to talk about that. But there's a lot of slides today. This is also something that I'm not asking you to write code about. Oh, there should be a space between web and socket. This is also something I'm not asking you to write code for, as we talked about before. I also spoiled that it's not going to be on the quiz. I'm not going to give you WebSocket code to read either. WebSockets are confined to the interview. You're going to get an interview question about WebSockets, and that's it. So I'm going to go fast. If you're not fully comprehending what's going on, just make sure you at least get the idea. I'm going to show a lot of code today. If you don't really follow the code, that's fine. But if you get the general idea of what's going on, that's what we want. That's what I want to see. So with that, let's give... Oh, I better hydrate a little because we're going to do a fast-paced lecture here. And on the syllabus, it just says concurrency in general. I don't mention WebSockets specifically. So I had that flexibility of what to do. And my final decision was the quiz will only have actors. The interview will only have WebSockets. So be prepared tomorrow to read actor code and answer a high-level question on the interview about WebSockets. All right, let's do this. So 115, we had this problem that we wanted to solve. where in our HTTP server, where we want to send data to the client after a page loads, and we did that through an AJAX request. We had the page load, and then this client made an AJAX request to the server, and then that AJAX response had more data, and then more data is processed and shown to the user. This is nice to be able to get more data loading after a page loads. I'll try not to get too sidetracked today, but if you go to a page, pretty much any modern page now, when the page loads, there's no content. It's just the framework of a page. And then a little bit of time later, the actual content populates on the page. That's because you're making a request, you're getting the HTML, you're getting the CSS, you're getting the JavaScript. The JavaScript runs and makes a bunch of AJAX calls for the actual content to be loaded on the page. It's a very common design structure for modern websites. The problem with this is that we can't send information from the server to the client without getting an HTTP request. So what we want is what's called server-side pushes, where the server can send information to the client unprompted. We just want to send information to clients. This is how WebSockets, actually let me talk about polling. So our solution in 115 was polling. Just ask the server every second or so, hey, do you have new information for me? Hey, do you have new information for me? Do you have new information for me? It kind of works, but there are times where your data is going to be a full second old. You're not going to have that real-time communication. So our more standard answer, our newer solution, is going to be WebSockets, which is to leave a connection open between the server and the client and have the server and client communicate with a two-way communication. So the client can send messages to the server, which it always could through HTTP requests, but now the server can send messages over this WebSocket to the client unprompted because that connection is left open. In fact, this is how Twitch chat works, where you're chatting right now, is you send a message. There's a WebSocket connection between you and Twitch's server. It's going to send the message over that socket, that WebSocket, and then everybody else in chat also has a WebSocket connection with the server. So as soon as you send a message, the server says, oh, here's a message. I bet everybody wants to read this. And then it sends that message to everybody who's connected via a WebSocket without them having to send an AJAX request. They don't have to send a poll. They don't have to have polling set up. There's just a persistent WebSocket connection between everybody in chat and the Twitch server. And the Twitch server is that liaison. Hey, you sent a message. Let me send it to everybody's WebSocket. So everybody can see this message immediately, or at least immediately minus network delays. So within a fraction of a second, you're going to see that message after somebody types it. Yeah, it's like a river. WebSocket is like a stream of data. You can always send information down that stream whenever you want. So how does this play into concurrency? That server, the Twitch server, needs to be doing multiple things at the same time, which is our definition of concurrency. We have multiple things or multiple methods running at the same time, multiple things happening in our program at the same time. Our one piece of software is doing multiple things at the same time. When the Twitch server is connected to everybody in chat, the server has to be listening for messages from any one of you at any given time. So the server can't be just doing one thing at a time, because what if two of you send a message at the same time? The server has to handle that. And in fact, the server is keeping all these connections open at the same time. So it needs to have code running for each of your connections, which is going to imply that it needs some sort of concurrency. There has to be the ability to run concurrently, or else you would only be able to have one user connected, which is not a very interesting app. It's not a very interesting chat service. Nobody can even read. The one person who is lucky enough to get connected, nobody can even read their messages because those messages can't be broadcast. So to get more than one user, especially when connected with WebSockets, we need concurrency. And that's how WebSockets apply concurrency, is to have multiple connections between multiple users simultaneously. That's only done through concurrency. Everybody good on that one? WebSockets apply concurrency in the fact that they have to have multiple connections simultaneously. They have to be listening to messages from multiple clients. So Socket.io is a library built on top of WebSockets, which is going to add a few new features on top of WebSockets themselves. WebSockets are just to communicate bytes of information back and forth. Socket.io is going to add a little bit of, some quality of life features on top of that. Namely, it's going to maintain our connections. If a WebSocket connection ever gets disconnected, Socket.io is going to reestablish that connection. It's going to say, hey, server, looks like we got disconnected. Hey, let's get reconnected. And it's going to do that seamlessly in the background. It's a very nice feature that Socket.io offers. It also adds this idea of message types, which makes WebSockets work very similar to our actors, which is why I use Socket.io in 1.16, because it has a very good parallel to actors. So actors sent message types, either case classes or case objects, to each other. Case objects if it's just, hey, this event occurred, or a case class if there's information that needs to be shared, needs to be sent to another actor. Sockets using Socket.io behave the same way, except all of the types of the messages are strings. And then for our purposes, all of the data is also going to be only strings. And if we want complex data represented in that string, we're going to pull out JSON. We're going to use JSON to communicate that information. So let's set up a Socket.io server. This is a new library. It's been in your pom.xml the entire semester. But if it weren't, you would have to add it, rerun Maven, install the dependency. You guys screwed when I mentioned HTTP, JSON, and AJAX. That's one thing. So this is a good and bad thing about web technologies. The bad thing is every little thing, anything in web technologies, for some reason gets its own acronym. The advantage to that is it looks great on a resume. You can spend like one day learning web stuff and put HTTP, JSON, and AJAX, JavaScript, CSS, HTML, all on your resume. To somebody who doesn't know any better, it looks really impressive. Where you can spend an entire semester studying CSE 1.16 and put Scala, maybe Maven, IntelliJ, I guess, if you want to put an IDE on your resume. So it's a good and bad. But don't get scared by all the acronyms. It's like AJAX is just JavaScript that runs asynchronously, making an asynchronous call to a server. It's nothing really new. We do that in Scala. We just don't call it something new. We don't give it a new acronym. So don't get bogged down by all the acronyms. It's debatably meant to be confusing. I think it's, I don't know. Maybe not meant to be, but that's the way it acts. Is like if you're a company, if you build a company that's making websites for your clients, and you start saying, oh yeah, we need to throw some JSON and AJAX and HTTP, HTML, CSS, and JavaScript at this thing. Oh, that's going to cost you. It can be used as a marketing tool. Not in a good way, but I don't know. Let me stop talking about that. So the first thing we need to do is import this library. So this is a simplified, I shouldn't say simplified. It's a pretty basic server. It doesn't have much functionality. It's going to be a chat server. So let's import the library. This is all the classes and objects we'll need for this library. And by the way, this isn't the full code. Connection listener, disconnection listener, and message listener are all classes that I've defined. They're just not on this slide. We will get to those ones. It's just hard to fit them all on this one single slide. Then we have to set up our configuration for the WebSocket connection. For this, we have to specify the host and port. We're going to say we're going to listen on localhost port 8080 for WebSocket connections. Very similar. I think you even used 8080 in 1.15, where you said this is a web server that's going to listen for localhost localhost port 8080. Same thing here, except we're going to listen for WebSocket connections instead of HTTP connections. Next, we're actually going to start the server. We're going to create a server object, give it the configuration, and then start that server. Now we're listening on port 8080. We're waiting for connections. And then to actually do something, so all that's boilerplate that would go in any code that you're running a WebSocket server. in Scala using this library. The rest is what you actually want it to do. So you're going to react to certain events using these listener classes. Very similar to when we did GUIs and we added listeners to our buttons and key listeners and mouse listeners. Same thing here. We're going to listen for specific events to occur and then call certain code based on the event that occurs. So we're going to ask our server, we're going to say, hey server, I want to add a connect listener, and I want to add a new connection listener as that connect listener. Now the server, whenever a new client connects to this server, the server is going to look for anything that was added using add connect listener, and then access these listeners for every single listener that was added. So these listeners are going to be called whenever that event occurs. Same with disconnect listener. Somebody disconnects, severs their WebSocket connection. We're going to access all the disconnect listeners and call them and have them do whatever it is that they do. Yeah, and absolutely, you can put OOP, FP, and concurrency all in your resume. I don't know, to the level we cover concurrency, maybe that's a stretch, but OOP and FP can't hurt to have them on there, I guess. And then event listener, this is whenever we receive a message. Whenever we receive a message over this WebSocket connection, what do we do? So for this, we're going to specify the type of the message, which is always a string in Socket.io. We're going to take the type of the message, and based on the type of the message, access a certain listener. So here I'm going to say whenever I receive a message of type chat message, this is the listener for that. This class should listen, or this object rather, should listen for those messages. So let's see how those listeners work. Or I'll start with the connect and disconnect listeners. Each one of these, connection listener, disconnection listener, whatever these objects are, they have to be of type connect listener or disconnect listener. Connect listener and disconnect listener are from the library. They were imported from the library. Disconnect listener, connect listener, right from the library. And then connection listener and disconnection listener, those are classes that I'm creating. So I'm saying class connection listener extends connect listener. And in connect listener, there's an abstract class named onConnect, which takes a reference to a socket and returns a unit. We have to override that method, and we override it and do whatever we want to do when a user connects. I'm not doing anything, I'm just printing to the screen that, hey, this user connected. We have a reference to the socket that's connected. So this is where, if we want to remember, if we want to store, like, hey, this user is connected, this is where we can do that. We have a reference here. We're inside of a class. We can have state variables here. We can, what I'll do later is pass. Actually, I don't know if I do that in the way I'm covering these this semester. But I like to take an instance of a server, so I have access to all the state variables of the server, and then add variables here that all the listeners can share. So they can share that information by communicating through the state variables of the server, and that's one of those sentences where if you follow that one, you're doing A-OK. And then disconnect listener extends disconnect listener, override on disconnect instead of on connect. Everything else is the same. Takes a reference to a socket and returns unit, and then we do whatever we want to do when somebody disconnects. So now whenever the server has a user connecting, since connection listener was added as a connect listener, when somebody connects, makes a WebSocket connection, it's going to call onConnect of our connection listener that we created, and then run whatever code this is with a reference to the socket that just connected. Same with disconnect listener. When somebody disconnects, we're going to call this onDisconnect method with the socket that just disconnected, and run whatever we want. All I know is that WebSockets keep the connection alive. That's not even true, though, Priest. Socket.io keeps the connection alive. Blitzkrieg thinks he gets it. Good. I like that. All right, and let's look at the last piece of this, the event listener. And this is going to take a string, which is a message type. And this one is saying, whenever I receive a message of type chat message, which is going to have some content attached to it that is a string, call this object's onData method with the socket, the actual data that was sent, which has to match the string. All these strings have to match. We're handling strings. Then an ACK request, which is something we're not going to use. We don't use in this class. This has to extend data listener with the type of the message that you expect to be handling. So we expect chat message to send a string, just the way that we're going to set up our server. We're going to expect the chat message to be a string. That string can be a JSON string, but it's going to be a string nonetheless. And then new message listener. This is a class that I create. This third argument has to be a data listener of type matching the type of the class that you give it here. And then override its onData method to do whatever we want to do here. So here I'm just printing out, hey, I received a message from the socket. Nothing too fancy. And then the next line, you're having trouble following the code, but you understand the concept, maybe? That's exactly where I want you to be at this lecture. If you're there, then you're doing great. If you can understand the code also, then you're just knocking it out of the park. You're blowing away expectations. So whenever we want to send a message to a socket, we're going to take a reference to that socket and use the send event method with either one or two strings. Two strings here. Since I'm using two, that's going to be message type. I'm going to send a message of type ACK, and I'm going to send a string with the content of that message. Here I'm just saying I received your message of data. I'm just acknowledging to the client that, hey, things worked. I got your message. Everything's good. ACK, short for acknowledge, is a network term. Is it weird that you understand the code as well? Hey, I ain't complaining. Are we going to interact with the WebSocket server? I mean, you don't have to write code to interact with it, but you can. I want to explain the code for those of you who do want to, maybe you want to use WebSockets in a side project or for your project contribution. I believe all three of the project contribution projects use WebSockets with this code. So I want to make sure that you, when you go into those projects, that you understand what you're looking at, or at least have a chance to understand what you're looking at. How about not understanding both? Damn it, Priest. So this is how we're sending information over a socket. So whenever we have a reference to a socket, we can send information to it. And whenever we're handling sockets, like when we handle all these connect sockets when they're connected, if we add these sockets to references to sockets to a data structure, and then whenever we have information to say broadcast, we can pull up that data structure and use send event on each of those references. Or there's actually a broadcast method in the server itself. We can broadcast to every connection, just because the library handles that for us. For damn it, Rin, now you get damn it, Priest. And if you don't want to send information, so this is like a case class where we have information attached to the messages. We're receiving a message that has information attached to it, and we process that information, and we're sending a message that has information attached to it. And it's all strings in this case. If we don't want to do that, if we want to do something similar to a case object where we just want to say, hey, this event occurred, or hey, I want to send you this message, then we're going to use class of nothing, data listener of nothing, data of type nothing, and then not access data at all. So if I get a message of type ping and I don't expect any information attached to that, I'm going to create a listener. Oops, that shouldn't be called stop listener. Extend data listener of nothing, and then do whatever I want here. Whatever I want to do to react to a ping message being sent. And then this is how we send a message that's similar to a case object where there's no information attached. We simply just use one string here. We only give one string to the send event method instead of two. We gave two strings when we wanted to send data attached to the message of this type. Now we're just saying send a message of this type, of type Pong. So socket acts as a server, right? There are two ends to the socket connection. Right now we're looking at server code. And right now we're going to switch into looking at client code. So there's two ends to the connection: a server that's waiting for connections, and then the clients, which will be your browser in most cases, that's going to connect to the server and establish that connection. Yeah, ping and pong, that's usually used to see if the connection is still active, yeah. And you can see that if you actually go into the browser console right now on Twitch, go to muted. If you go to inspect element, you know what? I made it this far and I'm not actually positive. I gotta think about it. If you go to network, refresh the page, sort by status, any status of 101 is going to be a WebSocket connection. And you can go to messages up here to see all the messages that are being sent back and forth on the WebSocket connection. If you watch this long enough, I believe, actually, yeah, this is because we found it out over not spring break. If you watch this long enough, there will actually be a ping message being sent and a pong response being sent, sent back. And that's Twitch checking to make sure that this connection is still open. So maybe I'll come back to that once it's been long enough that we'll see a ping pong. Whew. So let's talk about web clients. Everybody's perfectly understanding WebSocket servers, right? So now we need something to connect to our server. First, we're going to see this in the web world of the web, where we have a website wanting to connect to that client. So for this, I should have moved this over. So first we're going to set up the HTML of a page. I'm going to create just a really simple page here. And we don't have to get hung up on the HTML. I don't want to make this too much of an HTML. But we're going to have a few elements for a chat app, a place where users can type in. This will be a text box where they can type in their message. A button they can click to send their message, which will call send message, which will be defined in our JavaScript. A div, an empty div with an ID where we can get the messages from the WebSocket and add content here. And then getting our actual JavaScript code and also getting the library for our Socket.io client code. There are a lot of different Socket.io libraries. This is going to be a client-side library, a JavaScript client-side library, whereas before we had a server-side Scala library. But Socket.io supports libraries for a lot of different languages in both clients and servers. Oops, I already mentioned that. And then here's our code in WebSocket Client. First thing we need to do is create a connection to the socket. We need the host and port for that socket. If you leave this blank, it'll default to the host and port that served your HTML. So if your HTML server is the same as your WebSocket server, then you can leave all that blank. The way I'm doing it, it's not going to be the same. So I'm going to specify localhost 8080 because that's where my WebSocket server is listening. And then each time I want to react to a message of a specific type, I'm going to use this socket, and this returns a reference to the socket. I'm going to use the socket.on method, give it the message type as a string, and then a first order function, which is going to be called whenever a message of this type is received. So whenever I receive a message of type ACK, this function is going to be called with the content of that message, if there is any. If there isn't, so for example, in the Pong message, event would be, I believe, undefined in JavaScript in this specific library, but it'll be something that we can't, there's no content there. There's no content in this variable. ACK, we are expecting a string to be attached to that, so event is going to contain that string. I'm going to access my display message div and set its inner HTML to whatever this response was, so I can display that message display that content to my user. If we want to send a message to the server, we can use socket.emit. We have a reference to the socket that we created, and emit is going to send a message over that WebSocket connection for the server to process. Yeah, this is JavaScript code. This is in the browser. So we want to emit when the user clicks the button. We're going to pull whatever they typed into that chat input. We're going to blank out the chat input, that text box that they typed into, so they get a little confirmation that their message was sent, and then send it to the server in a message of type chat message, and then the message being the content that they're sending to the server. Everyone good on that? Told you this lecture's fast. This is like about a week's worth of content. Probably realistically two lectures worth of content that I squished down into one. Since I'm not asking you to write the code or read the code, I'm just going to fly through it so we have more time for other topics. This is the same chat app where you did Zelgo. It probably it's evolved over time. It's probably similar though. Actually, I think that was an Ajax one where we did that. I think that was an Ajax chat app. Desktop clients. Here's the magic of having a web server that doesn't necessarily speak web technology. So our WebSocket server doesn't serve, and by that I mean HTML, CSS, and JavaScript. Our WebSocket server doesn't touch HTML, CSS, and JavaScript, all the stuff that we need for the front end. That HTML and JavaScript we just saw would be served by either a different server or just open manually on your file system. It would be served by a different server when we go to deploy on the internet. Since our server doesn't speak those technologies, we can actually build different clients for the server. And this is another common thing in the world of the internet these days. Like, for example, Netflix has one server. Well, it has a lot of servers, but because they're huge. But they have like one server code, I guess, one server distributed system that handles the serving of all of the videos, all of the content, everything that we enjoy about Netflix. And then Netflix makes a new front end for each device that you might have. They have a web app, a phone app, a Roku app, an Apple TV app, an Xbox app. They have all kinds of front ends for all kinds of different platforms. But that's all those are the front end, and then they all connect to the same server, no matter what what platform you're using from. So they only write one server. They only write the server once. And then they write a new client for each one. Very similar to our MVC model, where you can replace the view and controller, but still use the same model. The model stays the same. It's the web server. The view and the controller can change. Same's true here. We're going to write a WebSocket client that's a desktop client for the app we just saw. Same functionality, but we're going to use a Scala GUI instead of using web technologies. This is absolutely something we can do. We don't need to go through a browser to use web technologies like WebSockets. We can write a desktop app. In fact, any game that you've played probably has networking included in it somewhere. But it's not a web app. It's still connecting to a server, but it's not a web app. You're not accessing it through a browser. So for this, we're going to pull in yet another library, another Socket.io library, this time a Scala client library for Socket.io. We're going to do the same things that we did in the web client, but we're going to do things just with different syntax because that's what this library is, and it's Scala instead of JavaScript. So we want to make it a connection. We're going to connect to the server, localhost 8080, and that's going to return a reference to the socket that we can use to communicate with the server. Whenever we want to respond to a message, we're going to use socket.on, same syntax we saw before, except things get a lot different on the other end of this. So when we receive a message of type ACK, we're going to create a new object of type process message from server, which is a class I wrote, which has to extend emitter.listener, and we have to override a method from emitter.listener called call, which takes a data structure of objects and returns unit. This is a Java library. I said Scala earlier, but this is actually a Java library. This is the first time we've seen object, something of type object in our code. Object in Java is like any ref. Is that right? Is like any ref in Scala. I believe it's any ref, not any. So we have a data structure of something. In our case, we're just going to be very careful the way we code, and in our case, we're going to know this is either nothing or a string. For ACK, we expect it to be a string. We expect this data structure to only have one element. So I'm going to pull the first element from that data structure, convert it to a string, and that's the message that we're receiving. And then I'm just going to print it to the screen because I'm not creative in this example. So there's quite a bit extra that we have to do to get our content. But most of this is just boilerplate. We're going to extend emitter listener. We're going to implement this method. If we expect a string, we're going to use this objects.apply of 0.toString, get our message, and then process our message however we want. When we want to send a message, socket.emit, and then more familiar syntax. Message type, and if there's content along with that message, the content of that message. If there's no content to the message, just give this one argument, just the type of the message. If it's like a ping, socket.emit, ping, and that's it. If you're interacting with a GUI, there's one more step you have to add to this mess up here, as if it wasn't a mess already, is this platform.runLater, which takes a function with no parameters and returns, I believe, unit, and then put all of your code inside this. What this does, so your GUI implements concurrency. It has multi-threading. It does some fancy stuff under the hood. What platform.runLater does is executes this code on the same thread as the GUI, so it can see the GUI elements. Otherwise, we wouldn't be able to see. This GUI because we're not on the same thread as the GUI. So a little extra stuff you have to do if you want to interact with a GUI. And here I made this an object, so we can say GUI client, just like you do song.cost function. I'm doing GUI client.text output to access the values of this GUI client, to be able to change the GUI and update the GUI based on WebSocket messages. Is an apply of 0 the same as head? Yes. That is correct. Okay, 5 minutes. So let's use what we learned here. We basically built a chat app already, but let's zoom out a little bit and see how we would build a chat app, which is actually in the repo if you want to play around with it. It's in the repo. You can run it. You can send chat messages to yourself and test out the code. There's both a web and desktop client to that. Run the server and then open the desktop client, open the web client, and you can see the messages being passed over the WebSocket connections. You think you're lost on the last slide, this one? To an extent, I am too. Just if you want to interact with the GUI, just add all this code up here, all this stuff. There's a lot of really intricate stuff going on here. It has to do with threads and GUIs and event threads. So let's build a chat app. Let's see how to do this. And here's our overall structure. We're going to have our server, our WebSocket server. It's going to communicate to a database and any web clients and any desktop clients that are connected to it, where the dotted line would be the internet. That's our network traffic. So our server is going to start up. It's going to open up port 8080 and listen for connections on port 8080, and then set everything up that we need to be able to implement this app. I have a lot of data structures. I shouldn't say a lot, but a couple data structures to remember which user is associated with which socket. I'm going to establish the MySQL database connection, which we didn't really talk about MySQL yet, so I'll gloss over this, but we're going to connect to a database so we can send so we can store the history of our chat in the database. We're going to register. So whenever a client establishes a connection, we're not doing anything on the connection when a connection occurs. But once a client is connected, we're going to ask them to send a message of type register containing their username as the data. When a client sends the register message, the chat server is going to remember, okay, this WebSocket connection is registered to that username. So messages from that socket are going to be treated as though they're from that username. When a user does connect, we're going to get all of the chat history from the database, and we're going to send the client a chat history message with a big old JSON object containing all of the chat history so they can catch up on everything that's been said prior to them showing up to the chat. The client's going to get the chat history, and whether they're a web client or a desktop client, they're going to have some JavaScript or Scala code, which is going to render all of that content to the user and display that in a way that they can consume it. They can read it all. The chat server, it has to be concurrent because we might have a lot of clients connecting, each of which might be a web client or a desktop client for what it's worth. So each time a user registers, we're going to store in a data structure, okay, this socket connection is for this user who registered with this username, this connection is for this one, etc. Whenever a user sends a chat message, they're only going to send the message, and I'm going to look up their socket connection and say, okay, what's the username for this socket connection? Get that username and then associate that username with this message that was sent. I'm going to store that in the database, and I'm also going to broadcast that new message to everybody who's connected. I'm going to say, hey, username whomever just sent this message, just letting you all know, and then each client is going to update their display, render that to the user, and show them that they got that message. If somebody disconnects, I'm going to remove them from all my data structures so they don't get more information from me, and I don't send information over a broken client. Let's clean up a little bit here. Twitch send us a ping. We send back a pong. Get some closure on that one. And that's the wrong data. That's the wrong repo. And we can do this quick. Let's run our chat server, which is going to listen for messages of type register. Register listener is going to take that socket and that username that they sent us and associate that socket with that username. I'm actually going to use two maps here. So I can go from socket to username and username to socket. Depending on which piece of information I have, I can get the other piece of information. So whenever they register, whenever they send a message, I'm going to broadcast that message. I'm going to use the server's broadcast operations to send this to everybody who's connected. I'm going to send them the new message, a message of type new message with a big old JSON string or a decent sized JSON string with that message. And whenever somebody connects, whenever somebody registers, I'm going to send them the history, which is a big old JSON string, which communicates with my database. I have a MySQL connection, and we don't quite have time to talk about that. Ooh, I don't know if I have MySQL running. We're going to find out right here. I'm going to run the server. If we don't have MySQL running, this is just going to crash. If we do have MySQL running, we'll see a chat app. Time will tell. So let's open my desktop app. On chat history or new message, we're calling add message or update. And when somebody sends a message, we're emitting. Oops. I have this set up with DMs. Was I messing with this code? I might have been messing with it. Anyway, let's open it up. Yeah, I have this set up as a DM server. Well, we don't get to see the demo. Can I establish connection to the database? Yeah, so I don't have MySQL running. Oh, that's unfortunate. We don't get to see the whole thing. But let me open the Gui client just so you can get the idea. The Gui client has the same functionality. And we would see the messages there.